Students of B.sc Part 1 and respected listener, a very good afternoon and welcome all of you to today's lecture. Students of B.sc Part 1, I am going to discuss today a very important, outstanding lecture. The topic I have mentioned on the blackboard, kinetics of first order of reaction. The topic I am going to deliver today, which is selected from B.sc Part 1 from paper 3, Physical Chemistry, selected from Unit 5th titled as Chemical Kinetics. Before proceeding today's lecture further, once again, I repeat the necessarily fundamental information terms based on chemical kinetics on our previous video, in which we were expressing about the definition of order of reaction, molecularity and pseudo order of reaction. I bring to draw your kind immediate notice on our the last video, in which we were defining about these three important terms, which actually proceed and help to us today's topic, the kinetics of first order of reaction. Order of reaction is the total number of sum and addition of all the living species active molecules participating present in any chemical reaction undergoing. It may be its further kinds of first order of reaction, second order of reaction, third order of reaction, zero order of reaction, and fractional order of reaction. In order to define the molecularity, the second term in chemical kinetics, molecularity in any chemical reactions is the addition of all the living and non-living, active and inactive species molecules whose total numbers to determine the stoichiometry of the reactions. Its further classification may be that is unimolecular, bimolecular and trimolecular. The existence of zero molecular doesn't possible. Students of B.sc Part 1, now question now arise here. Since the molecularity to define the figure, the addition, the sum of inactive molecules also, then why don't we eliminate such inactive neutral molecules? Students of B.sc Part 1, since molecularity to define the stoichiometry, the number of elements, atoms present in that is of reactant and that is of product. So, suppose we eliminate of inactive neutral molecules, I mean to say the symmetry, the number of moles of reactant and product elements and that is of atoms will be disturbed. Unbalanced, the number of moles either of reactant and product in regard of elements will be unbalanced. So, inactive molecules, their presence cannot be eliminated here. Next one, that is a pseudo order of reaction. How we define that is a pseudo order of reaction? Third one term. In our last video we have defined. Pseudo order of reaction, normally it is the fundamental concept in chemical kinetics. All the reactions undergoing to have that is of same order of reaction as that is of the same number of molecularity. I mean to say unimolecular reactions to have the same first order of reaction. Similarly, bimolecular reaction to have second order of reaction and trimolecular reaction to have that is of third order of reactions. But due to the natures of the chemical reactions and reactants, it has been observed that there are so many chemical reactions are known in the field of chemistry in which order of reaction and molecularity are found in different numbers. Such reactions are known as pseudo order of reactions. It happens on the behalf of two factors. It can be explained on the behalf of two important factors. First one, which is mainly concerned the excess concentration of one reactant which is present, whose excess concentration doesn't influence the velocity of the reaction in such a position. The velocity of the reaction is dependent upon the low concentration of that reactant which is present in low concentration. The specific example in our last video of chemical kinetics, we explained hydrolysis of an ester and inversion of sugar. In these two important examples, specific reactions, in both of these two important reactions, due to the excess bulk concentration of H2O, doesn't influence the concentration of the whole chemical reactions or doesn't influence the velocity of the reaction. In such a condition, the velocity of the reaction, rate of the reaction dependent upon the low concentration of ethyl acetate, and that is of sucrose. So it is the famous and well-known example of pseudo order of reaction. The molecularity in both these two examples one can express, that is of 2, I mean to say bimolecular reaction. Next one factor which is mainly concerned for the distinction for the difference of order of reaction and molecularity, that is mechanism. There are so many typical reactions are known in chemistry, in the environment of physical chemistry, in which reactions undergo more than one step. Out of one step, rest steps undergo fastly. One step perform slowly. This step which is performing slowly, to define as that is of a rate determining step, velocity determining step, then we have to count in velocity determining step how many number of reacting species molecules are present, then we have to count the total number of figure to give and to define the order of reaction. Three important specific example in our last video. We explained decomposition of first one, nitrogen pentoxide, treatment of peroxide disulfide with that is of iodide minus, third one that is of nitrogen dioxide with treatment that is of fluorine. So on the behalf of various mechanisms, all these specific reactions undergoing in more than that is of one step. After one step, that step is moving fastly. This term, the step which is moving slowly, we have to count the total number of molecules or reacting species, which is velocity or rate determining step. Now, after the completion of these various important topics, now it is the turn to discuss today the kinetics of first order of reactions. Students are unaware about kinetics, how many points, theory, features must be listed while answering in chemical kinetics. When the numerical or the question set in such a way, describe or write down the important note on kinetic of first order of reaction. They respond their answers, the answer in limited way. They write down first 1 point or maximum 2 points. But all the students of B.sc Part 1 now may I have appealed to you to write down the kinetics of first order of reactions depending upon that is of 5 or that is of 6 points. First one, that is of determination of or definition of, that is of rate equation, velocity equation. Second one, kinds of rate law or velocity law, which is further kind, that is of differential rate equation, integral rate equation. Students have to write also about the graphical representation in kinetics of first order of reaction. Next one, postulate students have to respond and the calculation of half-life period for first order of reaction, calculation of Wilhelm equation, solving of numerical problem, and specific example based on first order of reaction. Once again, I repeat, in the kinetics, the description of kinetics of first order reaction dependent upon 5 or that is of 6 points. First one, calculation or definition of rate law, rate equation, its classifications. Second one, that is of graphical representation for first order of reaction. Next one, that is of calculation of half-life period. Calculation, right? Students have to write down the theory of Wilhelm equation, numerical problem, and a specific example for first order of reaction. These were the various important point students have to write down complete information in kinetics. Now let us turn to define these one by one. Once again, I appeal all the students of B.sc Part 1, when question is said, is asked in any kinds of examination, write down the kinetics of first order of reaction or second order of reaction or third order of reaction or zero order of reaction. Then students have to answer, students have to complete their notes, their preparation on the behalf of 6 points. First one point to describe, that is of kinetics here, definition of rate law or rate equation, its classification. Next one, that is of what will be the size, shape for graphical representation. Next one, that is of calculation of half-life period. Next one, the calculation of Wilhelm equation. And next one, that is the numerical problem we have to discuss, we have to solve also based on first order of reaction, and a specific example based on B.sc Part 1. These all these important postulates, features, points to define as, that is of chemical kinetics of first order of reactions here. Now the title I am going to discuss here, that is of important postulate. Let us try to discuss one by one here. That is of definition of rate laws. Rate laws for first order of reaction is also known as, that is of rate equations. First one theory, first one points we have to explain in kinetics, that is of the definition of rate law, and that is of rate equation. Students do not respond exactly. How will you calculate, how will you define the rate law? Rate law is also another name I will mention on the blackboard, as that is of rate equation. The quantitative relation, the relation between, that is of rate dx by dt, velocity constant k, and that is of concentration A minus x. Their relation to define, their mutual relation to define as, that is of rate equation. Once again here, the relation which is mainly concerned mutually on the behalf of three quantities, rate, velocity constant and concentration, to give the define their mutual relation, to define as that is of a rate law. In coming timing, we will derive the topic I have mentioned. Now let me allow to join to you tomorrow. Till then, thank you very much.